Hey, Math 20-2, today we're going to look at dividing radicals. So let's investigate the division properties of radicals. Use a calculator to determine whether the following statements are true or false. So radical 20 divided by radical 10. That gives us 1.41. That is definitely not 2, so this is false. Radical 15 divided by radical 5. Let's try that one. Square root 15 divided by square root. Divided by square root 5. And that's supposed to be the same as radical 3, so let's see if that's the same as square root 3. Those numbers look identical, so we would say this one is true. All right. Square root of 7 divided by square root of 2. Square root 7 divided by square root 2 gives us that value. That's supposed to be the same as the square root of 7 divided by 2. Let's see if they're the same. Exactly the same. So they are, that's a true statement. D, 12 root 6 divided by 3 root 3. 12 radical 6 divided by 3 radical 3 gives us this value, and that should be the same as 4 radical 2. Incorrect. However, we made a typo on this. All right. Back when I did 12 radical 6, and this is a common error, it means 12 times the square root of 6 divided by, and when I wrote 3 radical 3, I have to put that in brackets. 3 square root 3. That should all be in brackets. Otherwise, the calculator would say 12 times radical 6 divided by 3 times radical 3. We don't want it to be divided by 3 and then multiplied by radical 3. We want it to be divided by the whole thing, 3 radical 3. So now that should be the same as 4 root 2. And it is. So 4 root 2 and 12 root 6 divided by the whole thing, 3 radical 3, they're the same. So that is a true statement. So make sure you use your calculators properly when you do that. All right. So I've done the first 4 with you. I'd like you to try E, F, G, and H on your own. Pause the video, see what you come up with, and then write a rule which describes the process of dividing these radicals. There you go. All right, so what you should have came up with. E, 10 root 18 divided by negative 5 root 3 is indeed negative 2 root 6. So that's a true statement. Cube root of 14 divided by square root of 7 equals square root 2. That is false. We can't do that. Cube root 14 divided by square root 7 is not the cube root of 2 either. Cube root 14 divided by cube root 7 is cube root of 2. That is true. So based on the results, write a rule which describes the process for dividing radicals. Well, we have it right here. All right. To divide radicals, the index numbers must be the same. We're going to divide the numerical coefficients. Then we're going to divide the radicands. And then we're going to simplify if possible. All right. So let's do that. Example 1. Divide and simplify where possible. So radical 70 divided by radical 7, we divide the radicands, keep the radical sign. So 70 divided by 7 is 10. The answer there would be radical 10. Here we would go 15 divided by 5. Numerical coefficient divided by numerical coefficient is 3. Radical 18 divided by radical 3, we keep the radical sign. 18 divided by 3 is 6. All right. Do the coefficients first. 20 divided by negative 4 is a negative 5. Radical 40 divided by radical 5 is radical 8. And now simplify where possible. Well, this is the same as saying negative 5 times. Find a factor of 8 that's a perfect square. Well, that's 4 and 2. So negative 5 times radical 4 times radical 2, which would be negative 5 times the square root of 4 is 2 radical 2, or negative 10 radical 2, multiplying radicals, which we learned last time. Square root xy divided by square root x. Well, we keep our radical sign. And what's xy divided by x? Well, x divided by x is 1, so we're just left with radical y. All right. And for part E, divide the coefficients. 10 divided by 20 is 1/2. Radical 24 divided by radical 2, we keep the radical sign, and 24 divided by 2 is 12. And again, we can simplify radical 12. So it's going to be 1/2 of the square root of 12. It can be written as square root 4 times square root 3. So we get 1/2 of square root of 4 is exactly 2. There is no square root of 3, so we keep the radical sign. And 1/2 of 2 is 1, radical 3. That's simplest form. All right. Example 2. Simplify the numerator and denominator, then divide. So we've got radicals that are not in simplest form, so let's do that first. So 4 times radical 54. Well, radical 54 can be written as, how about radical 9 times radical 6? And radical 8 can be written as radical 4 times radical 2. And now I could simplify these. I could say that 4 radical 9 times radical 6, how about that same as saying 4 times. Square root of 9 is 3. There is no square root of 6. And 3 times square root of 4 is 2. No square root of 2. So when I'm finally done simplifying those radicals, I get 4 times 3 root 6, which is 12 root 6, over 3 times 2 root 2. 3 times 2 is 6 root 2. And now I can go ahead and divide. 12 divided by 6 is 2. Root 6 divided by root 2 is root 3. So once I simplify those radicals, it's simplest form, nice and easy. Part B. Again, let's simplify the radicals and then divide. So 8 root 126 is the same as 8 times the square root of two numbers. We need one of these radicals to be a perfect square root, and they have to be factors of 126. So I think if you go 9 times 14, we get 126. Do the same thing with 12. We need the factors of 112. One's a perfect square, so that would be 16 and 7. So I now go ahead and simplify. 8 times the square root of 9 is 3. There is no square root of 14, so we keep that as radical 14. Square root of 16 is 4, and there is no square root of 7, so we keep that as radical 7. And now I have 8 times 3 root 14, so 8 times 3 is 24, square root 14 over 4 square root 7. And now we can divide. 24 divided by 4 is 6. Radical 14 divided by radical 7 is radical 2. Excellent. All right. Divide each term in the numerator by the denominator, then simplify. So really, what this question is saying is radical 20 divided by radical 5. Add radical 40 divided by radical 5. Subtract radical 90 divided by radical 5. So every term in the numerator must get divided by radical 5. So you could write it out like I just did, or you could do that in your head and then divide. So radical 20 divided by radical 5, you keep the radical sign. 20 divided by 5 is 4. Plus radical 40 divided by radical 5, you keep the radical sign. 40 divided by 5 is 8. And finally, radical 90 divided by radical 5, you keep the radical sign. And 90 divided by 5 is 18. So I'm done dividing, but now it says simplify. So the square root of 4, well, that's pretty straightforward. That's 2 plus radical 8. I could rewrite that as radical 4 times radical 2. that's radical 8, minus radical 18, I could simplify that as radical 9 times radical 2. So what I have is 2 plus radical 4 times radical 2, same as 2 root 2, minus radical 9 times radical 2. Square root of 9 is 3, and there's no square root of 2. So I'm done simplifying the radicals. Now I want to combine like terms. These are both radical 2, so I can combine those. So I've got 2 plus 2 minus 3. Positive 2 minus 3 is a negative 1, and you keep your radical 2. All right. So there is the answer to the original question. All right. Simplest form. Let's look at something called rationalizing the denominator. Usually answers are written in simplest form. For example, 1/6 plus 1/3 equals 3/6. We would write that as 1/2. All right, 1/6 plus 1/3 is the same as 2/6 will give us 3/6. And we wouldn't leave it as 3/6. We would write that as 1/2. In the division of radicals in this unit, we're going to regard simplest form as the form in which A, the denominator of the fraction is a rational number. In other words, it does not contain a radical. The denominator being the bottom part of the fraction does not contain a radical. And B, the radicand does not contain a fraction and is expressed in simplest mixed form. So the part underneath the radical sign is not a fraction, and it's in simplest mixed form. So the process of eliminating the radical from the denominator, in other words, converting the denominator into a rational number, is called rationalizing the denominator. We're going to get rid of the radical in the denominator. The process involves multiplying numerator and denominator by the radical denominator and then simplifying. That's all we have to remember to do. The radical denominator can be expressed in simplest mixed radical form before multiplying numerator and denominator together. So, complete the following work to rationalize the denominator. That means eliminate the radical from the denominator. So I've got 1 over radical 10. We don't want to have radical 10 in the denominator. It told us how to do this. It said right here, the process involves multiplying the top and bottom, numerator and denominator of the fraction, by the radical denominator. So whatever the radical denominator is, we're going to multiply the top and bottom by that. So my radical denominator is radical 10. So I multiply by radical 10 over radical 10. How can I do that? Well, what is radical 10 divided by radical 10? That has a value of 1. So if I multiply anything by a value of 1, the value stays the same. So we're going to change the way this thing looks, but we're going to keep the value the same. We're multiplying by a form of 1. Radical 10 over radical 10 has a value of 1. It's just taking a different form. All right. So let's go ahead and multiply. 1 times root 10 is 1 root 10. Root 10 times root 10, we've done that before. That's just 10. Well, that question now has a rational denominator. So we've rationalized it. The number 10 is a rational number. The number radical 10 is an irrational number. So we've changed 1 over root 10, which had a radical in the denominator, into root 10 over 10, which does not have a radical in the denominator. That's all we're doing. If you check on the calculator, these both have the exact same value. And you can always do that to see if you got it correct. So 1 divided by root 10 has that value, and the square root of 10 divided by 10 should be the exact same thing. So we've changed the way it looks, but we haven't changed the value of it. All right, that's all we're doing when we rationalize the denominator. Change the way it looks, get rid of the radical in the denominator, but we're not going to change the value. So in part B, my radical denominator is radical 6. So I multiply by radical 6 over radical 6, which is really just like multiplying by 1. So we do this. Radical 20 times radical 6. Keep your radical sign. 20 times 6 is 120 over 2 radical 6 times radical 6. Well, you go 2 times 1, which is 2. Radical 6 times radical 6, we know, is 6. And now you want to simplify this. All right. So radical 20 is the same as square root 4 times square root 30 over 2 times 6 is 12. And we could write that as the square root of 4 we know is 2. There is no square root of 30. All over 12. And now simplify. 2 root 30 over 12. Well, the 2 and the 12 can reduce. That becomes 1 root 30 over 6. So that's our answer in rationalized form. So if you check root 20 over 2 root 6 and root 30 over 1 root over 6, they should have the same values. All right. Let's complete C. The square root of 18 fifths. Well, we know the square root of 18 fifths can be written as the square root of 18 over the square root of 5. And then I'm going to multiply it by my radical denominator, root 5 over root 5, which is really just like multiplying by 1. So root 18 times root 5, we keep our radical sign, 18 times 5 is 90. Over root 5 times root 5 is 5. And now we simplify the radical in the numerator. Radical 90 can be written as square root 9 times square root 10, all over 5. Square root 9 is 3. There is no square root of 10, all over 5. That's our simplest mixed radical once I've rationalized the denominator. So again, square root of 18 fifths and 3 root 10 over 5 should have the exact same value. All we've done is change the way it looks. All right. So let's try example 5. Express each numerator and denominator in simplest mixed radical form, then rationalize the denominator. So step 1 tells us to simplify the radicals first. So square root 500, I can rewrite that as square root 100 times square root 5. And square root 27, that can be written as square root 9 times square root 3. So what I get is square root of 100 is 10. There is no square root of 5. Over square root of 9 is 3, and there's no square root of 3, so I keep the radical 3. So I've simplified the radical. I now want to rationalize the denominator. So I'm going to multiply by my radical denominator, root 3 over root 3, which is really just 1. And I now simplify. 10 root 5 times root 3. 10 times 1 is 10. Root 5 times root 3 is root 15. Over 3 times 1 is 3. Root 3 times root 3 is also 3. Simplify this up. 10 root 15 I can't simplify, but 3 times 3 is 9. Now some of us want to simplify the 9 and the 15. However, root 15 cannot be simplified by the whole number 9 because they're not both radicals. And the whole number 10 and the whole number 9 do not have anything in common. There is no common factor between 10 and 9 other than 1. So that's our answer in simplest mixed radical form. Without a denominator, that's a radical. So we've rationalized it. All right. Part B. Let's simplify radical 240. Look for a factor of 240. That's a perfect square. How about square root 16 times square root 15? Over root 108. Let's find a factor of 108. That's a perfect square. How about 36 times 3? Okay, and let's finish simplifying here. I've got 3 times square root of 16 is 4. There is no square root of 15. All over square root of 36 is 6. No square root of 3. So 3 radical 240 over radical 108 in simplest terms, or as a simplest mixed radical, is going to be 3 times 4, which is 12, radical 15, over 6 radical 3. Now we could rationalize the denominator by multiplying by root 3 over root 3, but we could just try dividing. Sometimes that works. Right? 12 divided by 6 is 2. Radical 15 divided by radical 3 is radical 5. There is no denominator. Hey, I've rationalized it. All right. Example 6, a couple tough ones. Simplify the radical expression by first rationalizing the denominator, or part B by dividing each term by the numerator, each term in the numerator by the denominator. So let's rationalize the denominator first. Step 1, I'm going to simplify these radicals. All right, so let's simplify this first. This whole thing would be 2 radical 50, which would be radical 25 times radical 2, minus radical 14, can't really simplify that one, all over radical 2. So square root of 25 is 5, 5 times 2 is 10, radical 2 minus radical 14, all over radical 2. So I'm going to take that expression, 10 radical 2 minus radical 14, all over radical 2, and I'm going to multiply it by radical 2 over radical 2. That's how we rationalize the denominator. So my numerator, 10 radical 2 minus radical 14 times radical 2. Make sure every term gets multiplied by radical 2. 10 radical 2 times radical 2. Well, 10 times 1 is 10. Radical 2 times radical 2 is 2. Minus radical 14 times radical 2 is radical 28. All over radical 2 times radical 2, which is 2. So let's simplify this thing. 10 times 2 is 20. Minus radical 28 can be written as radical 4 times radical 7. All divided by 2. Which gives me 20 minus square root of 4 is 2. There is no square root of 7. All divided by 2. So we could leave it like that, but that's not in the simplest form. I should divide every term in the numerator by 2 now. So 20 divided by 2 is 10. And negative 2 root 7 divided by 2 is a negative 1 root 7. That's simplest mixed radical form. All right. Let's try it part B. Divide each term by the numerator first. So I've got 10 radical 2. Right? Here's our simplest expression. 10 radical 2 minus radical 14 divided by radical 2. So let's take the 10 radical 2 and divide that by radical 2. I've got negative radical 14 divided by radical 2. So 10 radical 2 divided by radical 2 divided by radical 2 is 1. I'm left with 10. Subtract radical 14 divided by radical 2 is radical 7. So that's a little bit easier method right there. Okay. So you guys have questions 1 through 16. Let's get after them.